Okay, so are there any questions on anything? So I'm going to post another quiz this week, and then our test will be next week, and then I'll put a couple of assignments up there. And so why don't I? So I'm going to share the screen. Then I'm going to share the. Well, I'm going to open up the PowerPoint slides, and then but I did put the equivalent PDF file up there because I was making some last minute changes. In fact, this one actually, yeah, I changed the program a little bit. I realized this slide is a small error in it. Okay, so let's see. Okay, so let's go back to so this is like a big thing that we're doing today. And so we're adding more, just learning more new tools to write a Java program so we can write more interesting and useful programs. So without loops, we might as well not even be programming. And so we'll do loops, and then the big new topics, the topics left are loops and methods and arrays. And that's before we get to the object-oriented programming. Those are the big topics left. Okay, so because loops and arrays go together, and we haven't talked about arrays, but arrays is a list, like a collection of, like a list of integers or a list of strings. And so, okay, so loops are really, especially loops are really not hard to write, I think, especially while loops. And we want to learn how to avoid an infinite loop. Because it is possible to write a loop in a way so that it never ends. And then your program is just, oh my God, what's going on here? Either you just see this output, all this output just pouring out on your screen, and eventually it stops because your program crashes, or your program just seems to come to a halt and nothing is going on. And when I see like a program you're running a program and all of a sudden it just stops, and it's not because of, the user hasn't requested, the program hasn't requested input. When it just kind of stops, it's probably because of an infinite loop. Okay, so here is, let's see if I can see this a little bit of myself. Okay, so here is the general format for a loop, and it's really not too bad. We just go while. While is a keyword. Remember, so keyword is a term that can't be used as a variable name. And it's just like if statement. Remember how if the first non-blank character after if is a left parenthesis? We have the same thing here, while Boolean expression. So the Boolean expression has to be surrounded by parentheses. And then we can have a set of curly braces. And inside the curly braces are Java statements. And if you just have one, and if it's just one statement, you don't need the curly braces, though I think the norm is to always put the curly braces in, just supposedly for readability. Okay. And then so that loop will execute. So what happens is you go while, and then you check, oh, is that Boolean expression true? If it is, you execute the Java statements. And then you go back up and to the top of the loop. You check the Boolean expression again. And as long as that Boolean expression is true, you execute the Java statement. So what a while loop does, it allows us to execute the same set of statements over and over again until that Boolean expression is false. And when the Boolean expression is false, we jump to the first statement after the right brace. Okay. And so if the Boolean expression is immediately false, we never even go into the while loop. So here, I think I have a simple example right here. Okay, so and I actually put up, and we'll actually look at the Java code. I put up a Java file that actually has two examples in it, but I thought I'd just put them both in one file. But so I have a couple of examples here. So let's just display, it's not the most exciting loop, but I think it's useful. Let's display the first 5 integers. So one way we could do this, and I could have unrolled, maybe I should include this in the, maybe I'll revise these slides, but what we could have done is just gone out and typed system.out.println j equals j plus 1, and then the print line 5 times. And so, so this is kind of the equivalent of, here, let me see, students, hopefully I'm not making this too confusing here. So what this while loop does, right, it starts the j out at 1, right? So we have to declare this variable. And then in the while, we see while j is less than or equal to 5. And so 1 is less or equal to 5. And then And then so we print out the value of j, and then we increase j plus 1. And then what happens is we go back to this line, right? We go back to this, okay, good. So we go right here. So it's false when j is 6. So we're actually going to do that 5 times. And then it should print out after the while loop is over. We should say after the while loop j equals. Okay, and then we print out the value of j. Let's just look at this one. And then you'll see actually I have 2 examples here. So this is basically the equivalent of, let's see if I can do this. I probably should have, let's try this, students. So what was I doing here? So this is, let's say I didn't have the while loop and I wanted to do this. So what you do is you go, we're printing out, because we're going to print out j, and then, well, I won't necessarily type the whole thing out. So let's say I wanted to print out j equals 1 through 5. Well, what would I have to do then? If I didn't have that loop, I'd have to go like, let's just maybe do a couple of these. And see, you'd have to do this 5 times. And see, but let's say, of course, whoops. See how and I'll do one more. I think we kind of get the point. So that code on the previous, it's not formatting, but so this code on the previous slide is essentially equivalent to this. We want to print out 1 through 5. Well, we can type out those print lines and the j equals assign j plus 1 5 times, but it's kind of tedious. There's a lot of reasons we don't want to do this. One, it is kind of tedious, and there's the more typing you do, the more likely you're going to make a typing error. So it just really increases the time to develop our code. But let's say we, for some reason, instead of printing out the first 5 integers, I want to print out the first 1,000 integers. We're not going to do that 1,000 times. And then I guarantee you, we're going to make an error. Okay, so so this is really compact. This previous slide, it's just nice and compact. And we can change that j less or equal to 5 to j less or equal to 1,000. So if somewhere along the line we decide we want to change our code, we just have to change one Boolean expression versus adding lots of line of code. And this is certainly a lot more readable than this. And again, eventually what we're going to do is we're going to work with collections. I mean, like a list like what's called an array, a list of integers or a list of strings. And then the loops and the arrays will really go together. Okay, so anyway, so this is, we don't want to do this. Okay, so this is bad. Okay. So we want to avoid this. Okay. Okay. So any questions, or just shout out if you have any time, or just I'll look. I think I can. Yeah, I think I can see here when it's when someone asks a question via the chat. Okay. So we'll look at the PowerPoint. We'll look at j equals j. Oh yeah. Okay. So so initially we're going to display the powers of 3. So initially. J is equal to 3 to the first, so we assign j equals 3 to the first, and we'll look at the actual Java file in a minute. Okay, so we're going to count, so I will actually represent the exponent. So I actually don't need to know what 3 to the 6th power is. I just need to know that we're going to iterate 6 times. So iterate means, when we iterate is 1 time through the loop. Okay, so we're going to go through that loop 6 times. So going through the loop and iterate basically means the same thing. Okay, so I is like the counter variable, and maybe a better name might be counter. Okay, so again, we're going to start out while I is less than or equal to 6. Well, that's true. 1 is less than or equal to 6. So in this case, so we're going to print out j, which is the power of which is 3 to the first. And so here it's this statement right here. To get the next power of j, to get the next power 3, we just multiply by 3. We're not going to use math.pow. Okay, so one thing about math, so when this prints out as integer, not as double, math.pow returns a number with a decimal point, and we'll learn later how to get rid of that. But also this is just more efficient because, well, I'll explain in a minute. And then we increase the exponent. This just keeps track of how many times so I basically is the exponent. Exp might have been a better variable now that I think of it. Okay, so let's go back here. Okay, so let me go back. Okay, just wanted to see what the next example was. Okay, so students, let's just share. Let's actually look at the real code. Let's see that this actually works. I'm not making this up. Okay, so I'm going to stop sharing. And this file is online, I believe. And now I'm going to share. Where's the sharing? Okay. Okay, so this is a more exciting example. We'll eventually get to. Okay, display integers. So this actually is both. Okay, so I decided to make this compact, and instead of having two files, I just put everything in one. Okay, so so let's just see here. I'll just comment this out. Let's just look at the first one. That way we won't get overwhelmed. Okay, so you see how, yeah, it displays the integers in consecutive order. And the thing that we need to know is, oh, here, this is an older version of this. Okay. Okay, so the thing we need to know is we evaluate, how many times do we evaluate? This is what I'm talking more about in my Math 140 class. How many times do we evaluate j less than or equal to 5? Well, we actually evaluated 6 times. So, right, so, okay, so evaluate j equal 1, 2, 3, 4, 5, and 6. It's false when j equals 6. So we're actually evaluating it 6 times. We go through the loop 5 times because when j equals 6, 6 less than or equal to 5 is false. So we print out, so display when j equals 6. So when j equals 6, we go to the first statement after the while loop, which is line 11. And so the nice thing about this, again, this is what I'm saying here. Let's say we wanted to, I mean, displaying integers isn't the most exciting in the world, but let's say we decide, you know what? I want to display the first 10 integers. See, this one character, just a couple keystrokes, and we changed, instead of displaying the first 5 integers, we're displaying the first 10 integers. Well, and then let's say we don't want to start from 1. Let's say we want to start from 4. So we can initialize that j to 4. So we start at 4. See, then we display from 4 to 10. So really, it's very easy with loops. All we have to do just with a couple of keystrokes, we can easily just change the output or what we're calculating. And here, one last example is, just remember that loop only executes. Well, first of all, let's say j is 4. How many times do we execute? I think it's actually, how many lines do we see? I think it's actually 7. You can count with your fingers if you want. 4, 5, 6, 7, 8, 9, 10, that's 7. And basically, it's last minus first plus 1. So we actually would see 7 lines of output. We'd actually iterate 7 times, I believe. Let's try this. We're starting j at 4. We're printing from 4 to 10. Yeah, there's actually 7. The loop generates 7 lines of output, and then we generate one more after the loop. So, okay. But let's say, just be careful here, students. So remember, you only generate a line of output. So the loop only executes, iterates, if the Boolean expression if the Boolean expression is true. It could be possible we write a while loop that never executes. So let's just change that j to 40. And what are we checking? Well, the first thing we do, j is assigned 40. And then we go, is 40 less than 10? And of course, that's false. And so you would actually just jump immediately to line 11 in this case. So let's just verify that. Yeah, see, we never iterate because immediately in this example, I'm kind of changing the numbers as we talk, but in this example, yeah, the Boolean expression is immediately true. So we're not guaranteed that a while loop even iterates 1 time. So it may never iterate. So if the Boolean expression is immediately false, we don't iterate. And then later at the end of the lecture, we're going to see how we better, it's possible to write a loop that doesn't stop. Yeah, that's like the finale. It's like we're leading up to this, the exciting cliffhanger. Okay. So let's see here. What else do we want to talk about here? I think that's it. Oh, since kind of what I'm doing right now, just changing the numbers. I know especially when I'm learning a new language, this is kind of the stuff I do. I just take a program, maybe make some small changes and just experiment and see what happens. And sometimes I learn stuff. Okay, any questions right now before we get to the second example? Powers. We're going to display powers. So I am going to just comment this out. So I'm just going to highlight this. And what I'm doing, most of the times this works, I'm going Control /. Yeah, so, and then, oh, now I got to declare this. Yeah, so in the original example, I had already declared the J. Okay. So students, so here we're displaying powers of 3. And so it should be like 3. If I did this right, it'll be embarrassed if it's not. Okay, 3, 9, whatever, 27. Let's try this. And if it doesn't work, we'll fix it. All right, so yeah, I didn't mess it up. Okay, so okay, so sometimes I do. Okay, so display, but that's, to be honest, students, I think it's where we learn a lot. We make mistakes and correct them. Okay, so in each iteration, instead of seeing this first example, we increase J by 1. We're displaying in each example, we're displaying J. So the first example, we incremented J by a constant. And so I think in your algebra class, or maybe in your calculus class, whatever you're taking, but I know you, Nick, I haven't taught Math 72, but I did teach the previous version of it, which is Math 70. I know we talked about sequences. So in the first example, that's called this is arithmetic, right? We're increasing J by a constant. Okay, so we get the next value of J just by increasing by 1 each time. And so here, this is what is this? This is a geometric sequence. So increasing, we have to multiply. So we're multiplying by a constant. Okay, yeah. So in this case, J is a geometric sequence. To get the next value of J, we multiply by a constant. Okay, so okay, and so look how, like in 18, that's all we do in 18. We just multiply J by a power of 3. And so the one thing that's kind of nice about this, well, this is something maybe you worry more about in Math 140 than in Math 130. But the thing with the math.pow, let's say we're doing we're going like, okay, so we're going up to powers of 6. Okay, so let's say I go math.pow 3 comma 6. So that just starts from the beginning. So it always, then we'd go, like, let's say math.pow 5, you go 3 times 3 times 3 times 3. We do it 5 times. And then we throw that calculation away. And then you go math.pow 6. Well, you're starting from the beginning again. We just calculated 3 to the 5th power. Why not use that value to calculate 3 to the 6th? So if we did something like this, and I'm just going to comment it out. Let's say I just go, this is what I'm talking about. Why don't I just print out math.pow? See, I is the, well, that would actually give me a compiler. See, in this case, yeah, you could do that. It actually would display the decimal point. But the thing here I'm saying here is that if you have 3 to the 5th, why not save it and use it the next time around instead of just throwing away 3 to the 5th and just starting all over again? Okay, so that's what we're doing here. We're saving. So first we start out J at 3. Oh, the next time, let's turn that J, just with one multiplication, we turn it into 9. And then in the next iteration, we turn, just with one multiplication, we take that 9 and turn it into 27. So in this case, it's just one multiplication in every iteration to get the next power of 3. Versus if we did math.pow, let's say we did math.pow 3 to the 6, well, that's 5 multiplications. And that's just something to think about, just like a coming attraction issue. So anyway, but yeah, but to get the powers of 3, we just keep multiplying. We initialize j to 3, and then in every iteration, we just multiply by 3 to get the next power of 3. So here we just, again, so just, so and again, you could do that with powers of 4 if we want. Now, again, it's not the most exciting thing, but we could just change this to a 4. Now we'll get powers of 4, okay? The one problem is that eventually these powers get so big, it'll get bigger than the, oh, wait a minute, no, I did that wrong, students. Gotta change it in 2 places, right? So we're doing powers of 4. It should be like 4, 16, 64. So we start at 4, in this case, multiplied by 4 every time. So the point here, it's really easy to go from powers of 3 to powers of 4. It's the exact same algorithm, right? So, so let's just go back, okay. Okay, so the one thing is if you make the exponent too big, you'll get bigger than the biggest possible integer. But that's pretty big. We don't really have to worry about that. So any questions right now on this? And of course, one thing, students, I'll just say one more, because I like displaying powers of a number. Let's go back here. Let's say we were going to display powers of 3, but we don't want to start at 3. Let's just start at, let's say we start at 27. Let's go back here and make this. So we'll go 3. In this case, I actually doesn't represent the exponent anymore, but we're going to do so we're going to start from 3 to the 3 cubed, and we'll go up to 3 to the 8th. Okay, I think this will work out. So we started, so then we'd be 27, 81. All I'm saying here is you don't have to start at 3. You can still do powers of 3, but you don't have to start at 3 to the 1st. It should print out 6 numbers, yeah, so, okay. That's pretty exciting. Okay, so anyway, so those are 2 simple examples. So before you, so if you're reading about while loops, I think these are 2 good examples to understand. Okay, so any questions on this, students? Okay, so I'm going to stop sharing and go back to the PowerPoint slides. And so let me go to, let's go back, let's share again. Go back here, share, share, share. Okay, so that's where we were. And then, okay, so why am I here? Okay, so let's go. So this actually, this is actually a participation activity. I thought it might be a little bit confusing, only they left out, sometimes these participation activities where they're reading data in from the keyboard, they forget to, I think maybe just for brevity, they don't actually include the prompt. So the example didn't have this statement. It didn't include this right here. It didn't include that line right there. So I just wanted to say what was going on. Basically, so if you actually look at that activity in section 4.2, okay, so this is an example of, how, again, this isn't the most realistic example. It used to be, we would write programs like this. Now, if a user is actually entering data from the keyboard, it's via a web page. But this is a good place to start, right? You got to start, and then behind the web page is more something like this, stuff that you would, wouldn't really, that the web developer is using. So, web developers write a lot of code like this. They use JavaScript and other languages. They use like scripting languages, but it's really very similar. Okay, so what we're doing is that the user is, so it's kind of similar to what I just showed you. We're displaying powers of 2. And now what they're saying is they're prompting the user, do you want to see the next power of 2? And they do it a good way, like they're just multiplying by 2 each time. They're not using math.pow. And they're starting at 2. And so they initialize, they have this variable which called user car. and they initialize it to y. So remember, a char value can hold a single character surrounded by single quotes, and then we can compare the char value with the typical relationship type, operators that create Boolean expressions. So while user char equal y, it's saying, is user char equal to y? And if it is, you display the current value of cur power, which starts at 2. Okay, so then you multiply that value by 2, and then the user then is expected to enter another value. And so you either enter, so you're going to enter a string, and if it starts with a y, then you'll continue. And if it doesn't start, and I actually didn't write the whole message out. If it doesn't start with a y, you won't continue. And so I have to be honest, I'm a little slightly bothered, but this is an example out of the book. Maybe it's a little advanced because, I mean, I noticed they've done this where they like, first, remember the screener.next? So they've declared like a scanner variable to read data from the keyboard. So remember what the .next method, next, not next line, but just next. Remember, so the user is entering a string, and next will read one word. It'll read up to the first space. And then that .charAdd is taking the first character. So you can enter any string you want. But what it does is, remember we learned charAdd last time? It takes a first, it's just extracting the first character in a string. So you can enter any string you want, and as long as it starts with a lowercase y, you'll continue. So I'm just adding a little to that participation activity just to clarify it. Okay. Yeah, so that expression, scnr.next.charAdd0 is all it's doing is getting the first character of the user's entry. I think it's a little advanced for this, but maybe this is how we get ahead by stuff like this. Okay, but any questions on that example? So this participation activity is similar to my Java file, except now you can keep displaying as many, instead of hard coding the number of powers you display, the user can just keep typing in y. Otherwise, let's go to another example here. So, here's another one. So I'm just showing, now all I'm doing right now is just showing interesting, this might be the most interesting example I have for a while loop. We're going to learn about another type of loop soon called a for loop. And for us, that's going to be a more important loop. A while loop is good for when you don't know when the number of iterations is not known ahead of time. And we're going to learn about something called a list, like an array, which is a list. And we're going to know the length. It's easy to determine the length of the list. So there's two types of loops, while loops that we're learning today, and for loops. And for loops are really what we're going to be using we're using for loops and arrays most of the time together. Or for loops and strings, because we know the length of a string, it's .length with parentheses. Okay, so let's continue here, students. Okay, so this is actually using Euclid's algorithm for calculating the, and actually, Mike, I realize I have to revise this. I actually have the code online, and I realize it's this last line that's not actually, see, I'm kind of destroying my original value of A and B. So the user, enters two values for A and B, and what this code will do, and students, I'm not going to go through the algorithm, right? I'm not going to explain why the algorithm works right now. If anyone's interested, I can write it up and you can read it if you want. It's kind of, you learn it in math. If you're going to be a computer science major, you eventually have to take a course like Math 265, and they get to this in there, this Euclid's algorithm for finding the greatest common divisor of two integers. Okay, so you read in you get two integers from the user, and then there's this while loop. While B is, and so basically, students, this code uses the fact that the greatest common divisor of A and 0 is A, right? Because everything is a divisor of 0, right? A is equal to 1 times A. So A is a divisor of A. A is a multiple of A, and 0 is equal to 0 times A. So A is a divisor of A, and A is a divisor of 0. So this algorithm is using this fact that the greatest common divisor of any integer and 0 is the integer. Okay. And so, so well, it's saying, well, b is not equal to 0. Yeah, so you save the value of a in some variable called temp. And also here, I guess it's also using this fact, students. Basically, this is what this algorithm, let me move this if I can. I can write this up, students, because this is probably hard to follow. The GCD of, where can I type this? I'll just type this below here. I'll do this so it's more. GCD of a comma b here is equal to the GCD. Basically, this is what I programmed of a mod b, and we stop when and the GCD of a comma 0 is equal to a. That's what this whole while loop is based on. Okay, so what I'm doing is I'm making b the left. So this GCD is so we're going to make the see we make this b the first value in the GCD, and then the second one is a modulus b. So basically saying it's the greatest common divisor of a and b is the same as the greatest common divisor of b, a modulus b. Okay, so if you're interested in numbers and stuff like that, this is interesting, but this actually works even if you're not interested in. So let me just look at the, let's just look at the Java code here. So I'm going to share, I'm going to stop sharing. And they have a different version of this in the, they have a more, I think it's a simpler, I don't say simpler, but a different version of this in the Zide book. So here, I programmed this. And so I realized I'm destroying, I have to actually save the initial value. Can everyone see that? Wait a minute, did I share that? Did I share the screen?
No.
Okay, yeah, I thought that was, yeah, I thought that, okay, yeah. Okay, now you should, yeah, I didn't see all of you in there. Okay, so I just programmed that this is actually online. You have to save the initial value of A and B because you see what's going on in that loop. In every iteration, I'm changing A and B. So I'm going to loop. This is actually kind of a, this is probably what I'm doing there on lines 9 and 10. This is actually probably one of the most important parts of this example. So we're asking the user for 2 integer values, right? A and B. And then what we do there is I save the value of A and B in these variables A init and B init. Because you see what's happening there in the loop 12 through 16 is that I'm changing the values of A and B. So if I don't do that, I'm losing the original values of A and B. So save the original value of A and B. You see how we change A? So we're changing the original value of A. So see there we're actually changing the user's input and the same thing. And then the next line, so that's why we have to save the original value. Okay, so let's just run this. And it's pretty wild, students. Okay, so how about I don't know, students. Let's just try 1120 is 600. Is it might just be no, probably is it 20 or something? I don't know. I'm just guessing. Oh, it's 40. All right. Okay, and I think that's right. So 40 goes into 600. Is that right? Yeah. And does 40 go into 1,120? It does. Yeah, it goes in like 23. Yeah. All right. So yeah, it's remarkable how it works. So, and again, in the output, see how in the output, why did we need to save the original values? Because it's this output statement. If I wasn't going to have that last output statement, I wouldn't need the original values of A and B. But this is actually what I had in, this is why I have to fix my PowerPoint slides. I tried this, oh my God, I have an error in here. This is what I have on my PowerPoint slides to remind me, oh, this is not good. This is what I had in the PowerPoint slides, which I'll fix. Let's just, what did I enter, 1120 and 600? So running it automatically saves our work. See how it says the greatest common divisor of 40 and 0 is 40? But that's not our original numbers. We want to display our original numbers. So this is kind of a good example. Of course, I didn't realize this till I ran it this morning, and I wrote this last night, and then I ran it this morning, and uh-oh, that's not good. So this is a really good example of how, sometimes we have to save our original data. And I have another example in these notes too here. So this is kind of a useful example of, this is actually a very useful example of while loops, calculating the greatest common divisor. So maybe we'll use this in a project later on where where the user actually, inputs a numerator and denominator, and then we can display the numerator, and then we can display that fraction in lowest terms. So that's really, with this algorithm, it's really not too bad. So is it okay to stop sharing? Any questions? Okay, stop sharing. Okay, so we're going to go back to the, let's go back to the notes here. Okay, so what's our next example here? Oh, so students, I am going to put an assignment up here, and I'll point this out, the slide 9. Basically, if you can do this slide, the slide 9 tells you a lot. So I'm going to put an assignment up where we ask the user for an integer. And it's really, I think it's easier than the last one. We ask the user for an integer, and then what we're going to do is we're going to just scan the integer and see how many, we're going to count the number of, let's say, like odd numbers. And if you can just parse the number, how do we get the individual numbers of it, let's say it's a 5-digit number, how do we get the individual numbers? So this is basically, this slide is the hard part. So to be honest, I think if you understand this example, I think you can do the next assignment really relatively quickly. But if you can't, just always contact me. Okay, so we're going to again, I'm not prompting the user. I'm assuming that, that we've declared a scanner variable so we can read data from the keyboard. And we're going to enter an integer, like a positive integer from the user. You see, once again, here I was smart. I'm going to save a copy of the original number, because what's going to happen is, in this while loop, I'm going to divide by 10. Okay, so, and then what we're going to do in this example, we're summing the digits of an integer. Now, I didn't actually put this up in I didn't actually write a Java file for this one, but we're going to sum so if we enter, let's say 1, 2, 3, what we would calculate is 1 plus 2 plus 3. So we're going to sum the individual digits of an integer, of a positive integer. I'm going to assume the integer is positive. And so we save the original number in temp. Okay, then it's like, well, temp is not equal to 0. So how do you get the number in the ones place of any like of a positive number, or even it doesn't have to be positive. Remember, you take the remainder when divided by 10. So let's say, like, remember, like, like 625. Let's say like 4, like mod 10. Isn't that just 4? So you take when you divide it. Remember, the mod operator is giving you a remainder. So when you take the remainder with respect to 10, you're always getting the number in the ones place, right? And then we just add that on to, so in this case, our sum would be, let's say the first iteration would be 0 plus 4, which we get 4. And now, do you see what's happening here? We're dividing temp by 10. See, this is why we want to save our original number. We don't want to divide our original number by 10. We actually want to keep our original number. Okay, so what happens that 754 divided by 10? Remember in Java world, it's only in this class, in Math 130 or any kind of Java class. See, the numerator is an integer, the denominator is an integer. You take the quotient of two integers, we don't get a decimal point. So on your calculator, you'd get 675.4. Remember, we just truncate. When the quotient of two integers, we just truncate everything to the right of the decimal point. And so in this class, we get 675. See what happens? We lost the number in the ones place. And then we go back up to the beginning of the while loop. And now our temp is 675. And you'd say, oh, is 675 not equal to 0? And that would be true. And then we just start this whole process again. And now you take the modules with respect to 10, you get 5, right? So what that loop does with only really just a few lines of code is one by one getting the individual digits and then adding them together. And then in the end, see how we go the sum of the digits in, and now see, this is our original number. This is why we had to make 2 copies of the user's entry. One is so we can keep the original value, and one is that allows us to work, to keep dividing it by 10. And so students, so now we could do all kinds of things with this, as I'm saying. So we get the individual digit. Oh, is this digit odd? Well, let's keep, you can just, instead of adding the numbers together, you can just have like a counter. Oh, let's just increase this counter by 1. So this loop, if you understand this loop, the next assignment I think will be relatively easy. I think the next assignment will be 10, 20 lines of code. And this is maybe a third of it at least. I don't know. So anyway, it'll be fun though. I think it's kind of fun. I mean, who you think before, if you didn't know anything about programming before this class, like, God, how do you write a program that looks at the individual digits of an integer? And now, here we are, what is this, week 6, and now you know how to do it. It's really not that many lines of code. But any questions on in this interesting example? So note when I say interesting, it's like my propaganda. Is this the next one? Is this the real exciting example? Oh, they have this in the they have this in the Xi book, and you typically see stuff like this in an introductory programming class. And again, I just want to say this is not the typical way. At one time we would write programs like this where, we'd open up a DOS window, and I did this a long time ago, and you'd run the programs from like the command line, which no one does anymore. But it doesn't hurt to learn how to do it. So basically, this is kind of similar to an example we saw, is that we're just going to keep adding values together until the user enters a negative number. And I didn't program this one up either, but they do have a simple example like this in the book. So again, here we prompt the user to enter an integer value. We read it in, get value from user. We start our, so this is typical. Then we're going to do this a lot. You see what we have this line right here? We want to compute a sum. Well, if we're writing a program that computes a sum, we better declare, you don't have to call it sum. Sum is a good variable name, but somewhere we have to declare an integer variable that holds the sum, and we initialize it to 0. Okay, so so the user is just going to enter numbers from the keyboard. So we ask the user to enter a value, and if it's positive or if it's non-negative, we add it on to sum. And then we just keep asking the user for values, and we just keep adding on to sum until the user enters a negative value. So they call this, we're using a sentinel value to end a loop. So in real, no one does this anymore, but but again, it's kind of a simple example to understand. And again, if we're learning while loops at the beginning, it's kind of a nice example to introduce while loops. And you do see it in the Xi book. You see it in almost every Java programming book. So is there any question on this one? Is it okay to go on? I think the next one's our exciting example. Let's see. Infinite loops. Okay, so students, first of all, everybody at some point will get an infinite. I get them all the time. In fact, I've actually posted examples in class that have infinite loops. Once I was teaching, there's a kid, I think he was only 15, and I put this example on the board. He goes, "Do you know you have an infinite loop?" This 15-year-old kid was correcting me. I like that. Anyway. Okay, so, but see what happens there, students? When you write a while loop, somewhere inside between the curly braces, you have to do something to make that Boolean expression false. And that's what we did in all these other, like back here, like here, let's go one, it's a little bit easier here. Yeah, here, eventually, see this made the Boolean, we increase I by 1, and eventually that makes I less or equal to 6 false. So eventually, what we have to do when we write a while loop, somewhere that Boolean expression must become false. Otherwise, the loop never ends. Um, so we initialize j to 1, and then we're going, is 1 less than or equal to 5? Well, of course that's true. So we print out 1. But notice we've never changed the value. The value of j doesn't change. So, okay, so we get to the right curly brace, which means we go back up to the while loop, and we check, is 1 less or equal to 5? Shh, kitten. Okay, so we keep checking, is 1 less or equal to 5? And it's always true. And so what you'll do is if you actually ran this code, you just see, it just the ones will just come pouring out on your screen. Eventually the program just crashes, like due to lack of memory or something. And I think you can do like Control-C, that might actually stop it. And then, okay, so we never actually get to, oh, I guess I should have changed that comment. I'll fix that. Comment doesn't really make sense anymore. Okay, but yeah, your program, we don't like this. But students, we all get these. And then, oh yeah, I forgot to do that. It's really easy to do because we're gonna, again, when we learned for loops, you're kind of forced to write some code that makes the Boolean expression false. It's kind of built into the structure where the while loop, we have to remember, we got to do something inside the loop to make it stop. So this is one example of an infinite loop. I don't know, here's another example. Okay, so yeah, so here's another example. I don't know if they have this in the Zod book. And I didn't see it, but it could, I mean, it might be there, but I didn't see it. This is the one that's a little more frustrating. Okay, so let's say here, do I have it on the, did I skip the page? Let's see. Yeah, right here. Do you see how I have that and we're so used to putting these semicolons in, we do it without thinking. So students, see that one? After the right, this is really very frustrating. After the right parenthesis, we have semicolon, and that's perfectly legal Java code. See, we could declare j equal to 1. So j is we've introduced j to the program. And then we go while j less or equal to 5. Basically, this is a perfectly legitimate statement. What it's saying is, while j is less or equal to 5, do nothing. And that ends the while loop. See all this code right, because of that we actually don't want that semicolon there. The way to fix it, this problem, is to get rid of the semicolon. Okay, but basically, so while j less or equal to 5, do nothing. Okay, and then and everything in the curly braces, everything from the left curly brace to the right curly brace is not part of the while loop. It's actually unreachable code. We can't get there because so what it's saying is, while 1 is less or equal to 5, do nothing, and you don't actually see any output on the screen. That's why this one's a little more frustrating than the other example I showed you. The other one, you see all these ones just kind of pouring out on your screen. When you see that, you know you're in an infinite loop. When the output just is coming out so fast that you can't even read it, and it's like, oh my God, the computer's broken. Here, nothing happens. And when I see this, sometimes students will call me over. This is when we're actually in the classroom. And students will call me over, hey, my program just stopped. And it could be because you've prompted the user for data and it's waiting for that. But the other problem could be your infinite loop. And the loop this loop is not printing anything. Right? There's no print line in this loop. While j less or equal to 5, do nothing. And so when I see that, it could just be that you're in an infinite loop. And this is usually the culprit right there. You put the semicolon after the right brace. And again, aren't we always telling you to put the semicolon at the end of a statement, except after a Boolean expression? Don't put a semicolon after a Boolean expression. It can make you unhappy. And I think I can explain it right here. While j less or equal to 5, do nothing. So the program is actually doing something. It keeps going, is 1 less or equal to 5? It's asking that question over and over again, and it's true. And the loop never stops, but we never see anything. So students, that's pretty much it about while loops. I did post a worksheet, and then later in the week I'll post a quiz for this, and then it'll be due on the weekend. And then I'll post your exam next week, and I'll put an announcement up today about everything that's going to be due next week. So, but any questions right now? And then maybe we'll just look at a few of the worksheet problems. And then I did put, and then there's also some good, I'm going to put a Zybook assignment for this. The Zybook assignment isn't two problems, I think are pretty good. Let me just stop sharing this. And then, let's see, hopefully I was smart enough to, and I think I put this online. We could do a couple. Does everyone see the, okay, so, oh yeah, here. Does everyone see I have a Word file that says worksheet of while, oh, that sounds, worksheet of while loops. I should say while loop. What was I thinking when I wrote that? Worksheet of while. Okay, so I probably need more sleep. But does everyone see that what output is generated by the following code segment? Let's just do a couple of these and then and maybe we'll skip around, then I'll let you do the rest. And I'll put and I have a solution file to put up there. Okay, so now one thing, students, is that I'm probably more likely to ask you to write a while loop than to give me the output, because, you know, since in a classroom I might ask this, but in an online class I don't think I will. But it's a good, you know, it doesn't hurt to, you know, to be able to, you know, if we can try to predict the output of code, that kind of helps us. So we're starting the A out at 1, right? And what happens, here's the key statement. So we're printing out A equals and then the value of A, but here, see, we're increment by 2. We're not incrementing by it. One thing, we just want to read this carefully. So we might think, oh, we just saw some examples where we're incrementing by 1. You don't have to increment by 1. So A equals 1, of course. I just did it. A equals 5 and A equals 7. Okay, so what happens is you're incrementing A by 2, but let's just remember what's going on. After you increment A by 2, so just, you know, we return to the top of the loop. So return and evaluate A less than or equal to 11. And so when A is 7, 7 is less than or equal to 11. So we print out 7, and then we add 2 to 7, we get 9. 9 is less than or equal to 11. So we print out A is 9. Okay, so then we increment 9 by 2, we get 11. 11 less than or equal to 11 is true. So we print out, So we print out A, we print out A equal to 11. And then what happens is eventually A becomes 13. Eventually A is equal to 13. And we stop. So I could have printed out, maybe a better problem would have been said to, maybe I'll add this to the problem. Just print out the value of A after the loop. So after the loop, if I actually had this statement right here, this would probably be a better problem. I'm not going to get the correct double quotes. Whoops. Yeah, the double quotes don't come out quite correct with Microsoft Word. So this would actually be A equals 13. So this, I think I'll add that to the problem. I used to give, in Proctor tests, I used to give this, and a lot of people would get that wrong. They would put A equals 11. They'd forget that, okay, remember that Boolean expression, A equals 11, it has to have a false evaluation. It has to have an evaluation that returns false. And so eventually we do have to evaluate 13 less than or equal to 11. So any questions on that, students? And so let's see here. How about, I don't know, if you see something that's interesting to you, but let's just maybe try, how about this, let's say write a while loop that displays all multiples of 3 from 12 to 99. So we're displaying multiples. We don't have to start at, 3. So I can just go into, let's say like X is assigned 12. Oh, Microsoft. If I could go into Eclipse, but then I'm jumping back and forth with this sharing. Okay, initialize X is 12, so it's putting in that double spacing for me. Okay, but now the real solution file won't have that. Okay. And so then this we just go, remember we just go while x, we want to display all multiples of 3 from 12 to 99. So we just go while x is less than or equal to 99. And then this go, I can just go, I can print out a message if I want, or just go plus x. So we print out the value of x, and then we have to increment x by 3. And that'll do it. And let's just correct this. Okay, so yeah, so if you actually copied and pasted this, you'd actually, Eclipse won't like those double quotes. You'd have to erase them and then use the real double quote that Eclipse likes. But basically, but this gets the point. So x starts out at 12, and then you evaluate, is 12 less or equal to 99? Well, yes, it is. So you print out x equals 12. And then the next time, right? The next time, so then we go, x is equal to 12 plus 3, which is equal to 15, right? So each time we increment x by 3, and eventually we what's the first value of x? Eventually, and that's what makes the loop stop. The loop stops when x is 102. Let's not forget that. Eventually, that x less than or equal to 99 better become false so we don't stop. So maybe we'll do one more here. And then I'm also available, and then you can ask me questions afterwards if you want. Now, how do I do this? Look at this. Well, maybe we'll do this one. Maybe we'll do 2 more. We'll do one where we, let's just try this one, students, because I haven't done one we haven't, in all these problems we've incremented. We haven't done one where we decrement. Okay, so we're going to display all values from 100 down to 20. So again, int, let's call it a is 100. So now we want to decrease instead of increase. And there's no reason why you can do anything you want in that loop. So while a, in this case, we want to know if a, we're going to display as long as a is greater than or equal to 20. Okay, so then we can just go system, we just print out the value of a. And now we have to decrement. See, and so eventually, when does it stop? Stops when a is 19, right? So eventually it's going to evaluate 19 greater than or equal to 20, and that's going to be false. So, okay, so I think, I just wanted to, I had some of these problems like, how many times does the loop actually execute versus we're not actually predicting output or writing output. So some of these you can just, are small enough, you can almost just, like here, let's just look at, like this one's not too bad. Like, okay, it's this one, like number 11. It's displaying, it's displaying all the multiples of 10 from 10 to 1,000. Well, what is it? It's 10, 20. If you actually print it out, how many multiples of 10 are there from 10 to 1,000? Isn't it 100? So how many iterations? So when I say how many iterations, in this case, like how many lines of output would you see? So you'd see a equals 10, a equals 20, right? So basically one way to do this, if you're really, you might just see this right away. This one might be simple enough that you can see. Just remember, so if we look at all the powers of, all the multiples of 10, it's 10 times 2, and then 10. We're not going to do this all the way 3. We want to get up to 1,000. So it's like 10 times 98. Whoops. That's 980. 10 times 99. 10 times 100. And see, yeah, so basically it'd be 10, 20, 30, and then the last three numbers were 980, 990, 1,000. You see, we're just counting all the multiples of 10. So you see, we're displaying 100 multiples of 10. So in this case,
Can you divide the two to get your answer for that?
in this case, because you're starting at 10. But let's say we started at 20. So you just have to be careful. So in this particular case, you're absolutely right. But just and also let's say if I said a less than 1,000, and then you wouldn't be counting the last one.
So number 12, would you divide 64 in 2 to get 32?
Well, in this case, you're doing powers of 2. So you're actually looking at the exponent. It's actually, in this case, it's log base. It's log base 2. I'm not asking you to know that. It would be log base, right? Because see how we're displaying powers of 2?
Okay.
So it's 2 to the first, 2. I'll do the fast way of doing this. See, what's the last one we're doing? Isn't it 2 to the, I guess it's so small I can do them all. See, it's actually the exponent. The exponent is telling us the number of iterations.
Okay.
Because it's a geometric. See, the like number 11, that was arithmetic, right? We're increasing a by a constant. Whereas in 12, we're multiplying by a constant. So in this case, it's the exponent that's telling us the number of iterations. Does that help? Or?
Yes.
So basically, it's like log base. Because we're starting at 2, we could actually have gone log base to a 64. But you have to be careful because we're starting at 2 to the first, right? If I started at some other power of 2, you just have to take into account what power you're starting at. And the same thing in number 11. You have to take into account what multiple of 10 you're starting at. Is there anything else that's interesting to us? A lot of these are, how many? Let's look at this one. I thought I had an interesting problem here. So how many? Okay. So let's look at 13. See, in this case, we got to be careful. Okay, so how many iterations are carried out by the following loop? It's just like the previous problem, but in this case, you have to know the powers of 2, which you see a lot in these courses, but after 64, it's 128, 256. 5 to what's the greatest power of 2 that's less or equal to 600? And it's 512, right? So this is basically what you'd be printing is. I'll just put it. It'd be 2, 4, 8. So those are the, and then the next one. And then see that it's false when a is equal to 1,024. So this stopping value here, I go a less or equal to 600. It's not a power of 2. So I kind of maybe that makes it a little more interesting. So you have to ask yourself, what's the greatest power of 2 that's less or equal to 600? And so if you know the powers of 2, you know that it's 512. So eventually, you see these problems enough that I know the powers of 2, or I know the powers of 10, or 3. It's the powers of 3 that maybe after a while, after 700, what is it? After that's 81, 240. I think after 729, I don't know it off the top of my head. But does that? So what was the question? Yeah. So here, you just have to be when you see these problems with the geometric sequence. Yeah, we just have to be careful and look at what's the Boolean expression that's making it stop. So in this case, how many iterations are there? You can actually just count the numbers of lines of how many numbers do we have here? 5? Is it 9? So it'd be 9 iterations because we're going from 2 to the first to 2 to the 9th. Yeah. So we're going like 1 through 9. So it'd be 9 iterations. So I'll let you look at these other ones, or maybe I'll even come with some more problems. But pretty soon we're going to do for loops, which is really maybe more interesting. And then we'll learn how to iterate through like a string. Because remember, the string has, it's later on in the Xi book, so I didn't put it in today's notes. But remember, the string has that caret method. We can actually get an individual character in a string using caret. So we'll talk about how to iterate through strings and maybe like how to count the number of A's, or take your favorite, alphabetic characters. See how many of those alphabetic characters are in a string. So I'm going to put the next Zybook assignment up soon, today, and I'll post an announcement. Are there any questions? So students, I'm going to stop sharing. I think I'm going to stop sharing if I can find it. And so students, I'll just stay here, and then I'll stay here until you have no more questions. I'll be the last person to leave, but if you don't have any questions, first you're allowed to leave anytime. You're not going to hurt my feelings. But if you have any, but I'll stay here until nobody has any, until I'm the only one here. I'll be like the last one to close the door of the classroom. And then I'll post this later.
You said you had a quiz on the Boolean variable expressions, correct?
I had a quiz.
For this week?
I had a quiz. Yeah, didn't I post a quiz?
Is it
Online?
quiz 5?
Is it quiz 4?
That was
Isn't it? Is that the one that's due today?
yes.
Yeah. And then I'm going to put one more quiz up before the exam.
Okay. Thank you.
Anybody else, Richard? Yeah, sure. So let me see if I can do this. I'm going to create a breakout room here. Because I'm going to stop the recording.